We're going to start looking at the sine, cosine, tangent as a function. In this first video, I'm going to focus on the sine, and this is really an intro. To think of sine as a function, you would just say, oh, we're just going to look at it this way. Nope. We're going to think of it as f of x equals sine x. Now, I think this could be a little confusing, so I'm going to go over is why we switch from theta to x. Okay. This stuff bugged me, so I want to try to, and I'm thinking it might bug you, that's why I want to go over it. So I'm going to explain why by a review. So here's where we started. We started with a right triangle. We had an angle, a base angle, theta, and we have a hypotenuse. And we defined various ratios. I'm just going to focus on the sine. So the sine was adjacent over hypotenuse. Now we wanted letters, so we called this x and we called this y. Okay, and so this becomes, the sine, that was wrong. It's the sine is equal to opposite over hypotenuse. Hopefully you notice that. And so that's going to be y over h. Okay. Okay. So that's where we started. And we used x and y for a lot of reasons. One is because the next step uses that. And also, in other aspects of math, it's still useful to think of it this way. That's kind of vague and not great. So our next step was to do this. We drew a unit circle. On the xy plane. And then the unit circle is x plus y squared is equal to 1. And remember, that 1 is equal to the radius squared. So the radius is 1. Okay. And then what we did is we went an angle theta, and we went around, and we looked at x and y, and we said, oh, the sine of theta is just going to be the y coordinate. And the reason is because if we look at this triangle, one way to think about it is, if we look at this triangle, we have our hypotenuse is 1. This is the y. So if you look at the sine ratio, it's going to be opposite over hypotenuse. That's going to be y over 1, and that's just y. Okay. So again, and we did similar things for sine and cosine. So that's kind of where we went next. And just I guess here's an aside. Is computing, like how do we know, for example, that the sine, how would we find out what the sine of 1/2 is? And let's say we're using radians. Okay. Well, the answer is you'd use a computer. Okay. Well, how does the computer know? The computer knows an algorithm that you would learn like in Calc 3 about how to figure it out, how to approximate it. That's way beyond what we know how to do, but the computer knows this algorithm. It's too complicated for this class. Okay, so that's where we stood. Now here's the next step. We're going to take out the theta and we're going to replace theta by x. So instead of sine theta equals y, and theta would be an angle, y is a ratio, we're going to change things. So we're going to think of sine x is equal to the function of x. And I just want to sort of picture this. We're basically just replacing theta by x. So I'm going to draw my circle. Still the unit circle. Unit circle has radius 1. So instead of theta, I'm going to go here. Okay. I know that my radius is 1. That's the hypotenuse. And then the point on the circle I'm going to call A and B, since I'm already using x. And then the sine of x is still going to be that point B. The cosine of x would still be that point A. So in a way, it's a cosmetic change, but it's kind of confusing. And I just want to go over this a little bit. So I'm going to call this the A and B axis. We're not going to use this too much, and so this unit circle will just use different variables. It's the same circle, just using different variables, okay? So I want to go over this, but the bottom line is we're going to replace theta by x. And we're going to think of our function as f of x is equal to sine of x. And we'll have the same thing for cosine x. I'll give it a different name, and tangent x. And we'll deal with all those in turn, not in this video. Okay. So what I want to do next is kind of show how this fact is that we have to use x and not theta is going to be reflected in Desmos. So I'm going to share the screen. Okay. Okay. And then we can still use, I mean, we can do stuff like this. We can say f of theta is equal to sine theta. Okay. Desmos will give us that much. Now, I'm going to take another aside. Notice I'm saying that we must use radians. So how do I know what to use? So I'm going to go to the settings, and I'm going to say, I'm going to specify that it's degrees. Okay. And we're always going to use radians. You reach a point with trigonometry where that's just what's used, and we're at that point now. So if you look at graphs in a math book, they're always thinking of theta as radians. And then you're going to say, well, what difference does it make? But I want to show you why it's so important. If I switch my units to degrees, notice how everything changes. Here, the graph is now flat. Notice it's thinking, oh, the sine of pi over 2, this isn't radians now, it's a number. Pi over 2 is about 1.5, so it's saying, oh, the sine of 1.5 degrees. Okay, so it gives us different answers. So, but if we go back and make sure we're in radians, it's going to be all good. So again, make sure you're in radians. Okay, now I'm going to try to build up a table of values, which I think is really useful. And I want to, instead of using x here, I'm say I'm just going to use theta. I don't care what Professor Alexander says. I get an error message. So I'll try to put something here. I can't even enter anything, so I have to look at the error message. Oh, first column may not be y, r, or theta. That doesn't leave much, so I'm going to use x. Okay, and then so this would now be sine x. Okay, oops, I didn't mean to have that y there. Okay, now it looks good. Now what I want to do for the last thing is just build up this graph. Here, I didn't mean to. I'm going to zoom out a little bit. I want to build up this graph. So I'm going to turn the graph off. And I'm just going to plug in a few values. We're going to plug in 0. I'm going to plug in 1/2. And we get, again, this is sine of 1/2 radians, sine of 1 radian, sine of 1.5 radians, sine of 2 radians, and so forth. So I'll do a few more. 3. So I'll just build up a few more. So we get a nice graph. Now, I'm going to put the graph of sine over, and oops, sorry, I didn't mean to do that. I'm going to turn that on. You see it just overlays that table of values. So the way that we build up and I should switch this to x too, just to be consistent. Okay. So the way that we build up, build up these graphs and to get them is to plug in a bunch of values, plot our points, and then figure out the curve that looks over it. And again, the computer knows how to do all this. Okay, so I think that's all I need to do today. I wanted to sort of go over why we use x rather than theta, and then sort of introduce the use of Desmos and make sure that you're always going to be in radians and not degrees. Okay, that's all I got. So see you in the next video.